I'm going to switch over and we're going to talk specifically about the sequence for our VAV box today. And after we go through this sequence, I'm going to talk a little bit about other sequences as we do things. Because believe it or not, the sequence that we've written here, while it's not simple, is definitely not a complex VAV sequence. There are many, many more complexities that we could throw into this that we have not. So your typical VAV box will run via an occupancy schedule. And I think I missed something in the chat from Ted. Sorry, Ted. Absolutely, and he put it in for everyone. Perfect, thank you, Ted. But yeah, there are a number of different considerations. The velocity profile across the sensor, flow area adjustment due to dampers and coils. Every VAV box has a certain set of characteristics. And as soon as you change manufacturers, as soon as you change the BTU output on your reheat coil or change the style of reheat coil, hot water to steam to electric reheats, those will all change the flow characteristics within a box, let alone changing the input diameter of your ductwork or the input static pressure. So again, we're kind of, with the VAV box, we're at the end of the system where everything else affects what we're going to be working with. So I pulled up the sequence of operation. This is in our shared folder. And don't let me forget, I've got a couple of other documents that I uploaded that I want to point out, but that was this morning. So our VAV boxes typically operate under an occupancy schedule. So your standard occupied, unoccupied mode. This box, we have not included a third mode, frequently referred to as unoccupied standby, or occupied standby, excuse me, which is commonly used in buildings like our schools, where we have some sort of occupancy sensor that says, while yes, we are in an occupied time period between 8 and 5 p.m., but there's nobody in this room right now, so we can let it drift a little bit more. Okay? That is something that is appearing in many more specifications due to energy requirements, trying to eke every dime out of our system that we can. So, but ours, we're just going with simple occupied and unoccupied mode. During our occupied mode, we have a total of 4 degrees of drift between our heating set point, our active heating and cooling set points. These will be dictated by your slider or potentiometer type adjustment at the thermostat, so that the user has the ability to set a general set point between 65 and 75 degrees. That's what we're shooting for here. This is going to be one of those points when you're going to utilize your translator type tables, that temp table converter from your raw resistance value to make these temperatures. I will tell you that most of the potentiometers that we use in our field on these thermostats are nothing close to linear. So do not assume just because you have a 10,000 ohm sensor that you can do a top and a bottom and range and be good between those. The middle is usually pretty close to the middle of their range, but as soon as you get outside of those 3 points, things are very unlinear. I don't know where he went after that. I saw him. So during unoccupied mode, we're looking for a 5-degree cooling setback. So we'll be increasing our effective set point by 5 degrees instead of the 2 degrees that we had previously. And our heating set point will be reduced by 10 degrees. Okay. We have chosen a non-symmetrical setback for this because it's something that students need to be aware of how to do from a task standpoint, and because we engineers will dictate a starting point for most of these setbacks and most of these adjustments, but they're just that. They're a starting point. Sometimes we have to let a building run for a little while, and depending on the situation, sometimes your building will recover much more effectively from a low temperature. It's easier to add BTUs to our building than it is to take away BTUs on a hot morning. So having that non-symmetrical setback is something that students need to at least be exposed to. And this may be completely different for your area of the country. This sequence is written by two people who live in the Midwest. So it is biased by that standpoint.
Robert, we're going to have different equipment, different constraints, different ways with different people. You obviously know that. And then if we make a case, I mean, obviously we want to complete this and take everybody through it. But if we make a case that we might agree or disagree or try something a little different, I'm sure everything's open on the table, right?
Absolutely. So this is definitely one of those standpoints where we in this workshop, we want you to succeed with how you want to succeed. We've got some basic functionality that is going to be pretty cut and dry, that's how it's got to be. But if you want to adjust some things, some minor details, that is acceptable. In the field, when somebody builds a new building, depending on what engineering firm and what firm is doing your commissioning work, you may have really tight specifications. And you may have an engineer who says, I wrote it this way and this is the way it's going to be programmed. I don't care what you think. I'm the engineer. And I've definitely run into people like that. You will run into other engineers who are, yeah, I wrote the sequence, but make it work, make the customer happy.
Yeah. And I have a severe disrespect for VAV systems. I just want you to know that.
That's reasonable. And that's also a difference between doing work directly for a customer versus contracted work through like a general contractor engineer type setup. Sometimes they can be very different because your customer just wants it to work and be happy with it. The engineer has a lot better grasp on code and things like that. Sorry, Bob.
One equipment question that probably would help all the mentors too is that if somebody has a built-in controller with that airflow sensor on it, is there a block already pre-built already? Yes, there is.
And thank you, Bob. I did forget to show that block yesterday. So for those of you using the FW-V controllers in your library, just drag out the pressure sensor.
I know we have some folks that do have the pressure sensor built in our group, so.
Yeah.
Michigan people are always difficult. They're like Milwaukee people.
All right. So another common task that VAVs will be required of is unoccupied override. So this is the situation where you have somebody who's in the office late and realizes that their office is no longer comfortable and goes and pushes the button on the side of the thermostat. There are many control systems that completely ignore the fact that they push the button and everybody moves on with life. And hopefully the person runs with the placebo effect that, hey, I pushed the button, I'm doing something. Other times we actually do program in the unoccupied override. And this is something that indicates to the system, hey, yes, we're according to the schedule, nobody's in the building or nobody's in this part of the building, but hey, somebody's here and we need to actually take care of them. So it'll do things like turn on an air handler, switch that particular zone from unoccupied mode to occupied mode from controls. but it doesn't necessarily disturb the other boxes around it. So in theory, hopefully it'll help a little bit.
So technically your override though, just so everybody here that heard you talking about standby, and wants to do that, it's basically the opposite of this.
Yeah, exactly. Variable volume terminal unit flow control. Okay, so this is going to be how effectively we're going to control our airflow and therefore our damper. When zone temperature is greater than the cooling set point, basically we need to cool. We are going to modulate our control damper to change our airflow, moving towards our maximum airflow from our minimum airflow. When the box is satisfied, we will stay at minimum airflow during occupied mode. When we're calling for heating, we're going to go towards a heating minimum set point. And if you get through everything else, one thing that we're starting to see in a lot of boxes is that they will start modulating towards a maximum airflow if the heat load is, or heat requirement is not satisfied within a certain period of time. Okay. That is something new. That is not something that is universal by any means across the country. And nor is the fact that we have a minimum heating set point that is different from our minimum cooling set point.
But Robert, if we're programming, a heating set point following a cooling airflow set point, I mean, if airflow is already broken, broken apart, depending on how you program it, like some of these, how it's worded, like what chases what on the control strategy is what it's going to be interesting to see how everybody's program is at the end. Let's go with that.
Absolutely true. There is a very high probability that with the number of people we have in here, we will not end up with a single program that is done exactly the same.
And with Ted's program and strategy, it's definitely going to be different in our group.
And that's going to be one of the great things. And that's something you're going to run into in every classroom. So giving your students the freedom to figure out how they want to program it is really a very useful thing.
Yeah, Ted said he wants feet per second too. He wants everything programmed, so.
All right.
What was that stretch goal, Robert? Sorry.
Oh, the stretch goal is after 10 minutes, if the heating requirement is, or heating call is not satisfied, that now instead of just staying at that minimum heating set point, we start to modulate our airflow to increase the amount of BTUs we're dumping into the space. So, until we get satisfied. And then we go back to our satisfied mode and return to our minimum requirements. Unoccupied mode works almost exactly the same as occupied mode. During a cooling call, we're going to modulate open towards our maximum airflow set point and tell the air handler that it needs to turn on and provide us airflow. Obviously, we're also working with a greater deadband range there. Satisfied mode, this changes a little bit. Instead of going to our minimum airflow because the building is unoccupied, we want to close the damper fully. That way, if another box is requiring air, we can reduce the overall air we're putting into the space, reduce the amount of energy, and focus on those areas where we do specifically need the air. Heating mode operates exactly the same. We're going to run to our heating airflow set point, and as a stretch goal, after 10 minutes, again, we try and increase our airflow to increase the number of BTUs so that we can return back to that off mode status. Okay. Questions on that? That's one of the most basic functions of any VAV box is this airflow concept. So if there's only one thing you really get out of this, focus here.
So Robert, you might want to talk a bit about why you don't fully close the damper when it's occupied.
Right. Thank you, Hedley. So the reason we don't close our damper fully, why we have that minimum airflow set point, during occupied modes is because we're assuming during occupied time that we have people in our space, in our zone. And ASHRAE has very specific minimum airflow requirements per person within a space. So that minimum airflow here at the VAV box is a derived calculation from that original ASHRAE number running through how much outside air they're pulling into the building via their air handlers. And so then the amount of air flow and therefore airflow changes within a zone. So, that cover you, Hadley?
Yeah, it's an IAQ issue.
Yeah, indoor air quality, absolutely. And do expect to see, we're already seeing changes as a result of the last year. And I don't think those changes are going to stop for a while before they settle back down into a new standard.
And as Peter pointed out, the increased airflow has so many, outside airflow that is, has so many added benefits to productivity and health and sick days and stuff like that, that I think that we're going to see different types of outside air requirements going forward as a result of COVID.
So Ted, you know, I need to throw this in. We have fire issues out here in Northern California, well, most of California now. We're about to get into another fire season. It hasn't rained out here in forever. And the whole business about outside air has been thrown into a tizzy because when there's smoke in the air,
you don't want to bring it in.
Yeah.
Yeah.
And the question has been, I will tell you on the VOC side, it is with those people that we teach, there is a major discussion in hospitals and other places about what do you do when you normally would bring in outside air when the outside air is smoky. And I don't think anybody's resolved that yet.
And for reference, what Hadley's talking about here, when he says VOC, that stands for volatile organic compounds. That includes everything from the carbon dioxide that we breathe out to the off-gassing of glues and plastics from the construction of the building, from carpet, from tabletops, all those kind of things, to individual people's body odor. Those are all examples of volatile organic compounds. And the list of things that we categorize there is immense. But
that concept, Robert, I think is going to be tied to the air quality index, whatever listed now nationally on every single weather service available now.
Absolutely.
Just like temp and humidity.
Yeah. And our concepts of bringing in outside air as fresh air very well will be adjusted, because there are times in certain areas, whether it's in California when they've got forest fires going, or in the middle of LA or New York City or Chicago, when the air quality is low because of other things going on. So we will be further evaluating, comparing whether the outside air is worse than the air inside the building and what to do past that.
Our air quality is always good. It just blows in the Gary.
One of the things that I know was done for at least a time in Las Vegas, because during the height of the summer when it was the hottest, instead of bringing in outside air to do the air changes within the casinos, they would actually dump in oxygen, like tanked oxygen or liquid oxygen boiling off into their air handling systems to satisfy those outside air requirements, because it was literally cheaper than bringing in and conditioning that mega hot outside air, because of, deciding to build a giant city in the middle of a desert. Anyway, far from the only place we have that concern. So there will be a lot of.
You just said they trickle in oxygen through their VAV through their. Isn't that
they
illegal?
Used to. I don't know if they still do it or not, but they used to.
If I remember correctly, there was a casino that caught on fire because of something like that. So.
Yeah, absolutely. Right. And I think that's why things change. And anytime that we come up with things like this, there's going to be a huge interaction between public health and safety, fire code, engineering requirements. It's going to, like I said, it's going to take quite a while for these concepts to be solved. And once the solution is found, it's going to take a while for everything to settle down into a new normal situation.
Yeah. Yeah, we don't want a repeat of Apollo 1. Yeah.
Indeed.
Was there any, somebody who saw our speaker last January on wildfires and air quality, what did he conclude, or anybody recall where things were headed?
I don't remember where he concluded. I remember there was a lot of discussion about the methodologies of recording and reporting that air quality.
Yeah, I don't think he had any solutions he was bringing.
It was more the observation of how the situation that exists and how we're currently monitoring it and raising the flag saying we really need to find a solution for this issue.
Yeah.
I think also that we're going to be looking at, because lack of oxygen isn't the major problem with indoor air quality. It's mostly getting stuff out. So
Agreed.
realizing when you have to get stuff out is going to be critical, because it seems like so much energy is spent conditioning air in commercial HVAC systems that, this is why we use 40% of the energy, is because we don't have effective ways to achieve our air quality goals and our heating and our cooling goals in ways that we could. And as you mentioned, we're 10 years behind in controls, but we're probably even farther behind in that in the actual architecture of the systems that will allow us to get to, to save 90% of the energy or something like that we're going to have to do.
Isn't that the Spaceship Certification? That's beyond League Platinum, right?
Yeah, but it doesn't, but you do have to have a bicycle.
Yeah.
Carlos, you had a question or a point to make.
Yeah, what's the current minimum airflow for a VAV system?
Are you asking for our programming purposes here?
No, just according to ASHRAE.
Ted, do you know that one off the top of your head?
I didn't catch the first part of his question. What was it, Carlos?
What's the current minimum
30%
airflow for a VAV system?
Somebody was talking over you the first part again. Could you repeat the first part?
What is the current minimum airflow for a VAV system occupied?
I don't know for sure what it is. It's actually going to be on a case-by-case basis for that particular room. You have to meet whatever your state code is. Once upon a time, it was a certain number of CFM per person in that space. Quite often that equated somewhere to around, I think it was 1 air change an hour, roughly. Somewhere on the order of 1 or 2 CFM per square foot, 20% opening.
Yeah, the reason I'm making this point is, for example, let's say you have a row of 10 offices and only one is being occupied. Well, you have an aggregate of fresh air in those remaining 9 offices that's not being used.
Yeah.
And so you actually can even lower the minimum airflow on the VAV box even lower for energy savings, and still have people being comfortable in that office.
And
the aggregate of the 9 offices are not being used.
That's where the occupied standby type mode that I was mentioning earlier comes into play. Not only do we let our set points drift a little bit further, we also typically reduce our minimum airflow down to 0 CFM. So we treat it more as an unoccupied space than an occupied space. So we're not using as much energy in those spaces.
It's based on how many people occupy it. Yeah.
Well, and can I also say that this is a great discussion, but it's going to take all morning to really sit through. The ASHRAE code is 62.1 for commercial spaces. Those numbers that are being mentioned depend on occupancy and some other things, but that's a ventilation air. That requirement is an actual CFM of outside air. The air that you supply in the room can be a mix of outside and recirculated. So there really isn't a fixed percentage. You know, we can't say that the minimum airflow is 10% of the maximum. It just doesn't work like that. It's a calculation, and that minimum airflow has to include a certain CFM of outside air, not just a percentage. It's a terrific discussion to have with your students, and believe me, it goes on for a class or two to kind of understand how you pick that minimum. It's not intuitive.
It's very complex. It can get really complex.
Yeah.
Really.
Well, I guess the point I'm trying to make also is that, you know, have the CO2 sensors gone down in price, where you could actually put one for each office? Because, you know, really, that's the bottom line. You know, you want to have that CO2
This is a lot
minimum
of it.
parts per million, so you have the fresh air requirements and not use up all that outside air energy.
This is a lot based out of the 90.1 guidelines. So, and I think they've even changed since 07. I think that there's even new requirements, but we could find that out.
2018, yeah, the 2018 requirements now.
Yeah.
So again, it's not just 700 ppm above outside anymore. It's depending on the space usage. It's depending on all this stuff. And like we said, I mean, this conversation we're having is literally like a 2-day conversation.
Yeah, and then
calculate not only calculate requirements. Yeah.
We'll go ahead and table the conversation for right now. I am going to add on to answer Carlos' question specifically on CO2. Yes, CO2 sensors are currently one of the two primary types of sensors being used as an analysis factor for indoor air quality, for demand controlled ventilation. And VOC sensors are the other one that is currently written into some specifications. And as far as the cost of CO2 sensors, are they affordable now? Largely no. And knowing the cost of the actual sensor components that these companies are putting in, the fact that you have to pay $200 for a CO2 sensor just tickles me like you wouldn't believe, because the sensors itself that they're basing this off of are, you know, a couple of dollars for the actual sensor itself. So the cost discrepancy there just bothers me.
Well, and that's only part of the cost, because you have so much.
It is. There's a lot of other design and everything, but yeah. And maintenance, because CO2 sensors, VOC sensors have an effective shelf life. So they have to be replaced occasionally. And that's one thing that few building owners are aware of when they get those as a part of their building.
And don't forget the calibration part of it too.
And calibrating them on a yearly or biannual basis. So,
Thank you.
not at all. Great
Robert,
question. And a
yeah,
great discussion.
I just wanted to mention briefly, I can put the link in the chat, but our friends at Taylor Engineering also have authored a set of VAV guidelines. All right, so
That's fantastic. If you would put that link, that would be really cool.
yeah, sure, we'll do.
Thank you, Larry. All right, we are going to progress on to our reheat section of sequence. We have two different, oh, go ahead, Larry.
Oh, no, that's it.
Okay. We do have two different sequence sections trying to address different groups that may have different hardware in your hands right now. Our first section is our electric reheats. So this basically says that when we have a call for heating, basically we're 2 degrees below our heating set point, we're going to turn on our first stage of electric reheat. We're going to run that for at least 3 minutes. If we are still running it 5 minutes later, we're going to kick on our second stage if we have a second stage. And we're going to run that for a minimum of 3 minutes. If you have more than 2 stages, just rinse and repeat with a delay between. Do pay attention to the note here, and this we're going to talk a little bit more here in a second. If you have a high discharge air temperature, you may need to increase your minimum reheat airflow to bring it down to a reasonable level. Okay, and I know there's going to be a question on why we're doing that, and we'll catch that here in a second, because I want to talk about our hot water or modulating electric or steam type reheat situations, where we have a 0 to 100% signal that we are sending out to a system. Whether you have an electric reheat with a SCR, which allows you to modulate the amount there, or if you have a hot water valve that has a 0 to 100% position, or if you're in an older building that has steam and you're doing that the same way. In those situations, when we have a call for heating, we want to modulate our valve or our heat signal to maintain a discharge air temperature of 95 degrees. Okay. Now, the reason for this is I suspect most of us in our labs are running a little bit smaller of a VAV box. Okay. If you have a big 12-inch, 14-inch VAV box, you can usually just let the heat rip and you're fine, because we have a significant amount of velocity coming through that VAV when we're trying to heat. So even if we have 120 degree air, 25 degree air, we have enough velocity that when it comes out of the diffusers into our zone, it has enough force to be pushed down into the occupied space within the building. But if you're working with smaller diameter or smaller VAV boxes and less velocity coming out of them as a result, sometimes that really hot, effective heating air doesn't make it down to the spaces where it's going to effectively heat your space. It's going to kind of hang out up at the top of the your zone, right along the ceiling lines, and just get sucked back into the return. This does a couple of things. One, it becomes very ineffective for heating your space, except right up at the ceiling level, which we very rarely care about. And it also means that we are dumping a lot of energy to heat that air and immediately returning it back to our air handler, which is going to spend energy to remove that heat from the air. So we are really defeating ourselves both from a comfort standpoint and an energy usage standpoint. So if we maintain our discharge air temperature at a reasonable number, depending on what system we have versus the velocity we're looking at, that can really effectively increase the functionality at the zone level for comfort, and strangely, on the energy side as well. Okay, that's the reason why we're looking at those discharge air temperature numbers specifically for this exercise. Of course, your discharge air temperature sensor can also be an amazing troubleshooting device when you don't want to get the ladder out and go look and see what's actually happening in the ceiling. Okay. Questions on or comments on our reheat sequence? And again, this is one way to do it. There are many alternatives.
So Robert, are you saying don't turn your VAV system into a radiant heat system?
I am exactly saying that, Bob.
Oh, okay.
It will work eventually. We do have systems where we'll put a radiant heating panel. They make them in like the 2x2 and 2x4 grid drop-in sections in certain buildings, especially in colder climates, as kind of an alternative to washing the windows. They work. It's kind of weird. They work better with the water, as Ted mentioned, because it's easier to pump. It's also much more BTU dense than air is, so that's much more effective. But trying to do it with air, yeah, unless you've got a specific reason you need to do it that way, it's not an effective approach, generally. Other comments or questions on our reheat sequence? Our last section here on the sequence, and this is a stretch goal, not because it's not important, because it really is. And that's high and low zone temperature alarms. This is something that you're going to run into in every commercial building that has zone control. At least hopefully you will, to some different extent. And that's a high and low zone temperature alarm. You know, we've gotten so hot that we're way out of range. Somebody needs to address it. We've gotten so cold, we're way out of range. Somebody needs to come address it. We have this set as a stretch goal because it's actually a fairly simple thing to set up. But depending on what type of system you're working with, what the programmer chooses, this type of thinking can live either at the VAV box level at your zone control, or it could live anywhere above that. There are systems where we don't even think about this type of alarming until we're at the building controller level. So it's really a very dependent user taste and system capability concept. So when we're looking at these alarms, when we're looking at occupancy, we aren't actually connecting to a system. You're just going to use whatever points are appropriate for your system to do that. Probably a Boolean writable on your occupancy and possibly Boolean writables for your alarms as well. We're not actually going to send them up to a system. We're not going to go through the efforts of making them do a real building alarm. That's much more involved. Final footnote, anytime we said parenthesis ADJ period, that means adjustable. So that typically means you're going to want to have a point set up so that the user can adjust that. This is a frequent verbiage used in engineering documents to say either this is a starting number or we want this to be user adjustable by the building owner for whatever they want. That's kind of where that discussion or that idea applies. So as you are programming, I very much encourage you to actually print out your sequence of operations and document as you go. As you get the hot water reheat, the first part of this set up, check it off. And I encourage my students to do this too. As you accomplish a task, check it off so that you know you've done it. This really helps, especially if you're working across multiple class periods to try and accomplish these bigger projects. So I even do it for myself professionally still. Yeah, I find it amazingly helpful. Anybody have any questions on that?
Little question, I should have asked it yesterday, but in this software for this EasyIO, the first thing is like following a schedule. You want us just to put a tag there, or is trying to,
yeah,
I've not used the
just drop
schedule.
in a Boolean writable point that you call occupied or OC or however you want to denote it.
Okay, we don't want to find the
to
schedule that populates Monday through Friday. Okay.
No, you're not going to use or I don't encourage you to use an actual schedule.
Okay.
That makes your testing very involved and more challenging than it needs to be.
Perfect. Thanks.
Other questions at this point? I've got one other point I need to make, but
Robert, I had a question. Well, just a comment and a question. One of the things we want to do is think about metacognitively, how does this exercise work as a learning process from a pedagogical standpoint as we're doing the exercise? But also I wanted to ask you, Robert, where would this fit in a curriculum? Or where does it fit in your curriculum, perhaps?
So where it fits in a curriculum is a really interesting question. And believe it or not, I actually do this lab as my second class. The first class is our rooftop unit lab that we did 2 years ago here in Omaha. And then this VAV lab is the next one. And they are both, or the VAV lab especially is really strongly focused towards programming and sequence of operation. They get a little bit of an intro of that in the first class, and then VAV is the second class. But this could very easily be a second year class from that standpoint. So where I put it doesn't necessarily mean that's where it's going to work for your program.
Yeah, and right now for our program, that this isn't even, we don't even get into this anywhere near this.
Yeah.
We will start doing that though. Ours is only 1 year program.
So, Robert, when you say this is your second class, you mean a whole semester long class, or are you talking about a class period?
No.
Because I was going to say, it's going to take me more than a class period.
Yeah. We work on a quarter-based system here, so I should probably fill in a little bit more than just saying second class. Our first building automation system class has one prerequisite of our HVAC electrical class that they have to take before they can do the first building control class. The second building control class, of course, they have to have already taken the first building control, and they also have had to take our commercial HVAC class, where we do talk about the systems that we talked about on Tuesday. So realistically, it may be the second building automation class, but really it is a second year class for our HVAC students. So, and our classes are 11 weeks per quarter. Our initial class is 2 days a week, 6 quarter credit hours, which I think is something like 4 or 5 semester credit hours. And our second BAS class is 4.5 quarter credit hours, which is 3 semester credit hours, and meets 1 day a week.
So, so this lab, this project would be a 3 credit course from our semester standpoint, or something like that.
Correct.
Thank you very much. That's very helpful. I was very nervous. I hate getting too far behind my students. I know I'm always behind, but I don't want to get too far behind.
All right, so your students do this in a whole semester and we're gonna do it all today. Cool.
That's right. That's absolutely right.
Bring it on. Let's go.
All right.
I'm ready, you ready?
Any other questions on the sequence? Okay. You will have questions as we get into the programming. Your mentors will help. I'll be floating around to help as well. One last note on sequence, especially when you start getting into more complex sequences. Earlier in our conversation, Frank brought up ASHRAE 36. That is a lot of new sequences that are targeted at being highly energy efficient for a building and effective for control strategies. And their VAV sequence makes this look like kindergarten as far as sequencing goes. There's a lot of sequencing that we're starting to see that isn't the full version of ASHRAE 36, where your air handler is going to pull all of the VAV boxes that it serves and is looking for what they need. Are our dampers most of the way open, or do we have a bunch that are backed off so we can reduce our duct static pressure? Can we increase or decrease our discharge air temperature at the air handler to more effectively serve the average need of the VAV zones? There is a whole lot of that. And there are companies that have been doing those type of sequences for a long time, but not everybody by any means. And your average building sequence will be totally dependent on what type of building it is, and honestly, the engineering firm who writes the sequencing. Because that can be a huge difference, even in the same city, in the same genre or building type, like two different hospitals designed by two different engineering firms in the same city, can have vastly different sequencing, even if they're, physically identical hospitals. So something to keep in mind.
Robert, since you got into that aspect a little bit, how much slop is there between the engineer's written sequence and the actual control company's installation and ultimately the technician and ultimately the building operator and the occupant?
Wow, that
I'm dealing with stuff like that right now. We in my company we put in turn and respond to most of our systems, especially our VAVs, our VAV systems and air handlers. And typically, as I go in to commission them, my first thing I do is I just check to see if there is a request to decrease discharge air temperature or discharge static pressure. And as soon as I see that, I realize that they have not looked at the actual sequence of ops, and I kick it back. Trim and respond is really neat once you understand how it works, but it takes a couple minutes to figure out, to wrap your head around it, to see how it actually works.
Absolutely.
So they're coming out there. We're seeing it out there. In fact, as we're building ours, we're probably going to put trim and respond code into our mock-up when we get it done.
Gotcha. So this is actually a really complex process. I'm going to give you an simplified, sorry, English is my first language, but that doesn't mean I'm always good at it. Simplified perspective of my experience as both a contractor and building owner or representative for how this process works. So your engineer writes their original sequence. And this is nothing against mechanical engineers. They have a huge amount of work that they have to do. But most of the programs that they went to that taught them how to be an engineer have one class about control sequencing, about building controls. And oftentimes that particular class won't actually be so much a controls class as a class that's focused on whatever that instructor really has a pet peeve for. So it may be a class that's entirely focused on a PID loop, properly tuning a PID loop. That's what it is for the controls class here at the University of Nebraska. Their controls class is 85% about PID loops. So from a building sequencing standpoint, that becomes a really big blank for a lot of engineers when they get into the field, especially when they don't have good mentorship within their own company or much experience. So oftentimes they will contact a controls manufacturer or a friend they've got that works for a control company and say, hey, how would you write this sequence? And so it often becomes a sequence that favors a certain control product line or contractor or whatever. But so initially your engineer writes the sequence. It goes out for bid documentation or bid to the contractors, and whoever gets awarded the bid writes their sequence and submits it back along with all the parts they're going to use in the submittal package. Now, so we've taken the engineer's sequence and we've translated it once into whatever language the control contractor likes. Sometimes this is a good translation straight across that somebody took some time with. Sometimes it's the control contractor looking at that sequence and going, well, that's garbage. We don't do it that way. We're just going to dump in our boilerplate specification for how we would do it and send it back to the engineer and cross our fingers that they don't really read it real close and don't make any changes. Sometimes they do, sometimes they don't. From my experience, very frequently the engineer will kind of scan through the sequencing, and as long as it's nothing glaringly obvious, then they'll kick it back and say, yeah, this is approved. So the sequence the control contractor specifies may be very different from what the engineer originally wrote. Now we've got the control documents and the programmer who's going to implement that sequence. This programmer who implements the sequence can have a varying skill level. So you may end up with an implemented sequence that's not, far from what the control contractor specified, said they would do, or it may be vastly different. And then at this point, we have interactions between the control company and the engineering firm who comes back to check to make sure things are done, and or a commissioning agent who takes the specification and double checks it to make sure you did what you said you were going to do. Then we get into the building operations. And typically speaking, when a building is turned over, the control contractor comes in and does a training session with the people who are going to be running the building. This very frequently happens about once. Sometimes it's a 4-hour session, sometimes it's an 8-hour session, sometimes it's a 5-minute session. And the control contractor does a huge brain dump of how everything is supposed to work within the building. Keep in mind that a lot of these control programmers are not your most people-friendly types, not necessarily good at presentations, things like that. Some are, don't get me wrong, but sometimes they're really not. So it's very technical information that the building operators may or may not be trained to understand effectively. So then we get into running the building. Keep in mind that control training very frequently happens once, right when the building's turned over. And yeah, there's more training specified in most engineering documents. Most control contractors kind of reserve that as coming back for warranty issues and, continued training, things like that. So oftentimes, if the original 5 people who run the building, when they leave, nobody comes back and does additional training for how the building was designed to operate, or programmed to operate is what I should say.
Yeah, Peter, I think Robert hit it. This is another class. This is your commissioning class. And commissioning should address deviance from design, how you deal with that, how you document it, how you train for it, how you update your systems manual, things of that type. Otherwise, as Robert just said, 5 years down the line, nobody's going to understand why the drawings and the program don't match. So this should be documented in your commissioning issues, and that, that's yet another class to be talked about.
Mm-hmm.
Yeah, Peter, I think the basic answer to your question is there is so much slop in the system for that it's unbelievable.
Absolutely. And it really relies on a lot of people paying very close attention and having very positive intent to get a good translation from initial design to operating the building.
Mm-hmm.
Carlos, you had a question or comment?
Yeah, that's unfortunate that some of the training is left out, because not only is it good customer service, but it's another marketing opportunity for controls contractor that they're really just missing out on completely. They don't know if there's other buildings to be had as far as that need controls work, and it's unfortunate.
Yeah, absolutely true. And it really is that end process is very contractor and individual dependent as far as how exactly it gets handled. Some contractors do a very good job of it. Other contractors do a very lackluster job of it.
Yeah.
Great question, Peter, and I'm sorry I can't give you a more positive perspective answer.
No, I think it's real, and that's one of the virtues of what we're trying to do in our classrooms.
Absolutely.
Whether we're working on the control side or the operations side.
Yeah.
if the technician understands more, they'll do better.
Yep. So, are there any other questions or comments specifically on the sequencing that we're going to deal with today? Because I think we probably need to move on here soon.
One of the things I want to focus on today, at least personally, is I want to be able to get my head around how to get the VAV dampers and the variable frequencies drive blower motor to work together. And I want to do that first with Sedona, try to get my head around how I would accomplish that, but also in the line item interface of my current gear.
There you go. I think that's a great focus. And for those who have variable frequency supplies, that is something, like I said, we are seeing Steve, I think it was Steve, yeah, put the name to it of trim and respond. It is commonly how that is referred to. So it definitely is, can be a complex sequence, but there are actually some ways that can be kind of simple to employ it. So, all right. And yesterday I issued a challenge to everybody and then completely forgot to talk about it this morning. And that was using a PID loop to create or to solve square root functions. So in situations where we're trying to solve a square root, really we can also square a function or square a number to figure it out. So what we're doing is we're taking our original differential pressure input and dropping it into our loop as the set point. So what we're trying to get to when we square a function, and then dropping the result of a multiplication table, multiplying 2 back into the loop. So we cycle back around and around. So as soon as we drop a value in, and with differential pressures, we're looking at small numbers here. We're looking at, at most an inch of differential pressure, which is a huge quantity of airflow in most situations, at least. So even if we're looking at half an inch, oops, if you enter it the correct way anyway, our loop will cycle through when we set it the correct way. You have to set it to indirect, and it will cycle through and figure it out for us. Oh, there we go. But we have to use exceptionally small KP for this, and a really surprisingly big KI, integral factor. Otherwise, it just creeps up on it and takes absolutely forever. So if you're ever in a situation where you need to figure out square roots and you don't have a square root function, this is a potential solution for you.
Some math guy took the time to figure this one out.
You've already insulted me by calling me IT enough times, Bob. Don't start calling me a math guy.
Don't start with the math.
That is one potential solution. Carlos also figured out a fantastic solution. Anytime you have access to a powers function raised to the power of n, just drop in 0.5 for that power and it'll perform a square root function for you. 0.33 if you're looking for a cubed root. So just wanted to talk about those. So overall, how is the project going? I don't think many people are close to being done, but it seems like we're making some really good progress overall. Anybody have anything in particular you want to share with how things are going for you and your team?
Yeah, the Michigan guys already have a front end built, graphics program, the whole nine. So you guys know, they're overachievers.
How's your group doing, Michael?
We're doing pretty good. We got our set points figured out. We've got our damper loop up and running. We were just fixing to get started on our staged heating.
Brad, how's your group looking?
If I can unmute myself. We're looking pretty good. We've got our set points, our inputs and outputs. Tomorrow we need to actually start on our damper sequence and then our heating sequence.
Cool. Bob, how's your group actually doing? We know
everybody's failing at this point. I just want you to know that right now. As of right now, they're all failing, including me. We're putting it together. We got our inputs, outputs. We're figuring out occupied versus once we have occupied set, then we can add all the other trains of thought there. But occupied to a string of damper control and understanding the limitations of the emulator. So.
Mr. McNabb, how's your group going? I know you're struggling a little bit, but.
They started out kind of waiting on me to see what I had, and I really didn't have anything. Chris Miller was a little bit farther along, but ran into the issues that you helped him with. I tried to at least get to some kind of basic logic that I could help Don and his cohort with, and hadn't quite got there yet. So we're still in the beginning. And then after listening to Bob, I realized, oh yeah, there is a occupied, unoccupied type of schedule that we need to set, and I have no idea what function does that.
So you're making progress though, is what it
Yeah,
sounds
making
like.
progress. I'm not sure what specific schedule function you use for occupied, unoccupied, or if you use it as a discrete input.
Discrete input is all we're looking for this project.
Okay. Well, then that solves that. So I should have, I'll throw something together this evening and share it with them, but I'd rather see where they're at, because I'm sure because of where we're at, especially Don's probably got a creative solution already worked out.
Yeah.
Just, we didn't have an opportunity to share it before I was called away. And then we know where Chris is, and Chris is pretty far along. And I'll have some kind of logic set for it, but I'm hoping to get some functionality out of my kit too. But I have to make some phone calls and have some discussions because they're not available. They're working.
Right.
And the workshop kind of interrupted our time frame for them to come in and help me learn to use the software, or give me training on software and help me get set up communicating with the controllers. So that kind of, it was not getting the stuff till Thursday that kind of made that issue.
Kind of put you in a pinch. I understand.
Yeah, but that's okay. Even though I don't have all the parameters loaded properly, I can work with each font parameters because they give you a pretty good log of what line item commands to use. And some of that, all that line item command is packaged into certain things. Like you can get a whole block that's PID, and you just put the ins and outs. And also certain other functions like that where you don't have, where you can get in and do line item things if you really needed to, but you don't necessarily have to. It's more set up on a spreadsheet.
Perfect. Awesome.
But using contemporary, well, using Sedona will help me at least get the logic worked out.
There you go. Andy, how's your group looking? Saw a lot of work going on.
Five more laptops floating around here.
Trying to figure out which one to talk into. I understand.
Yeah, well, last spring I took a C programming class, and actually Connie was my instructor, and now I'm trying to teach her this, and it's just not working out. We've got a pretty good tackle on the first page. We're just wrapping up the cooling logic get the dampers, and then we need an ASW to convert over to the minimum, to the min and the heating logic. So we got a pretty good run on it.
Fantastic.
So,
Fantastic.
Robin, what are you guys doing?
Well, we are still struggling a little bit with hardware. We ended up with our differential pressure sensor wasn't such a hot deal. It was in the center of the VAV box, and we had the fan, the radial fan, right in front of it, and we couldn't figure out why we weren't getting any differential pressure until I realized there isn't any flow out of the middle of a radial fan. So we now have 6 feet of duct, and we're starting to get some movement in there, but it wasn't lining up terribly well with with what we would expect given using the function. So we did a calibration on it, and we calibrated it and did a regression. And one of the things I found out about EasyIO is their natural log function doesn't work. It doesn't work at those low values that we're getting in. And so that was a learning experience.
Might be why.
So we decided we're going back to the formula, the 4,005 times the square root, but coming up with values that are significantly higher. So we may use, I'm trying to figure out what to do about that, because we can actually measure the flow rate. We've got flow meters. So I may use some sort of a fudge factor or go to the polynomial regression fit much better. So, even though we know it's a natural log relationship. So other than that, we haven't gotten too far. I did figure out occupied versus unoccupied, but that's because I knew how to do right Boolean. That was pretty simple.
2 things. One, the reason you're running into issues with that log is because Sedona doesn't do really small decimals particularly well. It has some built-in rounding that really is almost problematic. So if you multiply your initial value by 100 or something like that to bring it up into a more readable, and then divide your resulting log appropriately, you might get a more accurate answer. If that works with the logarithmic function.
I don't think it works with log. That's why we use logs, because they're not linear. You can't use that linear transform. But yeah, but that's good to know.
Is there a significant value that this Sedona uses, like 3 sig figs or some value? Because obviously the decimals, they truncate after the 100th place.
Yeah, that's typically where it truncates after.
But as far as positive, big numbers.
Places, sometimes EasyIO seems to go to 3 most of the time. If you push it, contemporary controls always seems to want to come back to the 2. So yeah. Okay. I haven't gotten a consistent answer for that.
But that is a good workaround. I like that that workaround for other things.
Yeah.
Thanks.
The other suggestion I would offer is you've got some flow to work with, some numbers. So instead of fixating and trying to solve that issue, work forward with the logic. Because you know how to solve your flow issue, or you'll figure out how to solve your flow issue. That's right. But it shouldn't inhibit you from making the overall progress.
Right. So I can just tweak the parameters, and that's what I figured. But I will be starting tomorrow with with a nearly blank slate and much more knowledge.
There we go. So the slate is never really blank. You're just building it more quickly. So one thing that I wanted to point out that Robert McNabb said was he didn't want to show the students his solution because he wanted to see what they come up with. That is absolutely how I work, and I love that approach because it forces your students to think and troubleshoot instead of just copying what you have done. And copying is pretty easy. Sometimes it has its own challenges, but the troubleshooting and the thinking to actually get to the result really works amazingly well. There are some students that you will absolutely frustrate to no end with doing that, but I'm not sure that's not always a bad thing.
That's better than them finding out that you don't know what you're doing.
No, I love it when they find out I don't know what I'm doing. I love it when students prove me wrong because it gives me a chance to learn. Ask me questions I don't know the answer to. That's great. Means I've got to go find the answer. It's fantastic. And it helps prove to them that no matter how much you know, there is always more to learn. And I don't think there's any industry where that is more of a truism than ours. So.
What was it Mark Twain said? He says, it ain't what they don't know that hurts them. It's what they know that ain't so.
There you go. We are running right at the end of our scheduled time today. So does anybody have any final comments that they want to share?
Robert, do we have to do anything special to save this? Like just save and it should stay right in the controller, and when I show up tomorrow morning, it should still be there?
Absolutely. So that is one discussion point that did come up that I forgot about. Thank you for reminding me, Matt. As we are programming this, both on contemporary controls and EasyIO, as soon as you save it, hit the save, or in contemporary, I think it's send to controller. The work that you've been doing live, which is live in the controller, it's in volatile memory at that point. When you hit that save, it shoves it down into the permanent memory in the controller. So as long as you hit the save button, you can turn off power. As long as your controller doesn't jump off the wall on you and die, you'll be good to go tomorrow morning.
Is there any way to work on this program offline and come back tomorrow and dump it back into the controller?
Yes, there is. You can.
Is it really difficult?
It's not difficult. The challenge is if you don't get exactly the right firmware on your emulated controller, and you work on it tonight and go to dump that
or kits
controller tomorrow morning, it will crash that controller, and you will have effectively lost all the work you did today and yesterday. So while it is possible, yes, I do not recommend trying to do it.
Is it possible to save offline? Frank had to leave, and he asked me to send the stuff over when we're done. So I'm working with the EasyIO controller, and I'm wondering if there's a way to save it on the computer and then send it to him.
Yes, there is. So I think I'm connected to something. Yes. Let me do a quick screen share. And in the EasyIO controls, it's all based out of that kit management section. So I'm going to run to kit management. And down here at the bottom, there's a button that says back up. Just hit that. It's going to save it into your files recent, and then whatever you're calling your controller in CPT. And just select your folder and away you go.
Thank you very much.
Not at all.
Where was that backup button? I'm sorry.
It's under kit management. I need to share the screen, not just change over to my programming tool. So if you're in your regular programming, come up to your toolbar and hit the button with the 2 gears, Billy. And then it's down here at the bottom. And then when it comes time to load that into another controller, a virtual controller or real controller, you'll just hit the restore button, navigate to where you saved that file, and away you go.
Yes, thank you. Thank you.
Other questions, comments? Ted, Peter, Larry?
It's just going to be interesting. I feel like we didn't get anywhere, but we covered a lot of ground.
Even if you're walking in circles, you're still walking, right?
Well, you know, one of the things that, you know, we had, I don't think one of the parts that is connected in the minds is the design side of it. How would you design this, and what do we have to think about, and what are the blocks? That's a lesson all in itself, just to go through. What are the blocks that are going to apply to this situation, and why? Even though you went through blocks to give an overview, it's why would I use this block and this reason, and then carving out all the sections of what you want to show people how to minimize it and compartmentalize it and start to develop it into something. That's the toughest part right there.
It really is. And
without giving them the answers, without giving all the answers. And that's why I'm not trying to figure the answer out before. So.
Yeah, that's absolutely a huge challenge. And I'll be honest, the way yesterday went, I know we got a lot of information across, but I personally actually didn't like the way yesterday went, because I gave you a huge amount of information all in one big lump sum, and it's really hard to digest when you do that.
Yeah, we were going over the same concepts. Yep.
Yeah. What would be a lot better in the way, if we had more time, I would have preferred to do it, would be to get some basics done in the programming, come up to a question, and then, okay, let's look at a couple of blocks that might be able to answer that question for you.
Exactly.
Step through it that way. I think that would have been a better way for us to have approached this. But with our time constraints and everything, I don't know if it would have been practical for us. So, but yeah, you're right. The design side of programming is there are classes upon classes in IT and computer science talking about exactly that topic. So it's challenging, inarguably. All right. So Melissa has requested I show tomorrow's agenda real quick. Just so
Robert, I'll call you after I talk to Chris a little bit. I'm gonna get that straight. All right, guys.
Take care, everybody, or whoever's signing off. Let me show the agenda real quick. Come on. So tomorrow's agenda, day 4, we're going to continue some programming, hopefully do some finishing up. And then Ted is going to lead us on some performance testing functions. Last thing we're going to do, of course, is come back as a group, report outs on what you found on this workshop that you liked. Hopefully our folks who are working on non-standard VAV solutions, Hadley, Chris Miller, others, will be able to show us, be willing to show us what they've got. So we can see that.
Hey, Robert.
Larry.
Yeah, you know, earlier today as we were doing updates, I did get some updates in the chat, and I'd like to just propose maybe at that 11:30-ish slot when we come back as a, you know, to the main group, right, that we, you know, take 5 minutes to allow people to, you know, make their announcements or what have you. I don't think it'll take that long, but I think Steve Gooch and Lanny were among those who sent me some updates, and maybe Chris Miller too.
Yep, I saw one from Chris. So yeah,
all right,
we absolutely can do that. That'd be fantastic. All right. Well, at that point, we are 10 minutes past our scheduled end time for the day. So I think we will call it a day. I'm going to be on for a little bit longer. I've got a couple of people who have specifically asked for help. So we're going to help those folks out, and we'll see everybody else who doesn't stick around tomorrow. Be safe, everybody. Thank you for your time.